Hey everybody, tonight we're debating whether or not the sun or the earth is at the center of the solar system, and we are starting right now with Ozien's opening statement. Thanks so much for being with us, Ozien. The floor is all yours.
Thank you, James, for allowing me to present my argument on modern day debate, and thank you, Ironworks, for being my sparring partner today. I'm Ozien. It's beyond my belief that somebody actually believes that the Earth is flat or that it's the center of the universe, so this should be fun. Let me start by saying something I know we all can agree on. The Earth ain't flat. Now, I know some of y'all might be thinking, duh, of course not. But let me tell you, there's still some folks out there who argue the Earth is flat. And to them, I got to ask, you ever trying to plan a vacation using a flat Earth map? Now, I know some of you might be thinking, but wait, isn't the idea of a round Earth just a theory? What if it's all just a giant conspiracy? Well, let me ask you this. Have you ever played tetherball? You know that childhood game where you hit a ball attached to a rope and it spins around and around, never falling to the ground? Well, think of the sun as a pole and the planets as balls. The rope in this case is a bit stretchy and elastic. We call that the force of gravity, pulling the planets in an elliptical orbit around the sun. And just like the ball on the tetherball rope, the planets will either be pulled into the sun or continue to stretch out into the vast expanse of space. Now, if that's not a scientific explanation for the heliocentric model, I don't know what is. So let's go over a bit of history about the three musketeers of science. Copernicus, Galileo, and Kepler. These brilliant minds were the ones who really stuck it to the geocentric model and proved beyond a shadow of a doubt that the sun, not the Earth, is at the center of the solar system. First up, we have Copernicus. This Renaissance man was a true trailblazer, and he was the first to propose the idea that the sun, not the Earth, was at the center of the solar system. He was a true revolutionary, and his ideas were so revolutionary that the Catholic Church couldn't deny them until 1616, when they prohibited the theory. But as they say, the truth will set you free, and Copernicus's idea eventually became widely accepted. Next, we have Galileo. This guy was a real troublemaker. He was the first person to use a telescope to study the night sky. And what did he see? He saw that the Earth was not the center of this universe, and the planets orbited the sun. This was such a radical idea at the time that Galileo was put on trial by the Catholic Church and was forced to recant his ideas. But as history has shown, Galileo was right, and his ideas eventually became widely accepted. Lastly, but there's other important people, we have Kepler. This mathematician was the one who finally put the final nail in the geocentric model coffin by showing the planets orbited the sun in elliptical, not circular orbits. Kepler's laws of planetary motion provided the mathematical proof that the sun, not the Earth, was at the center of our solar system. And with that, the heliocentric model was finally accepted as a scientific fact. These laws of planetary motion were used to predict the location of Uranus and Neptune. It was just proved beyond any reasonable doubt that the heliocentric model is true. So there you have it, folks. The three musketeers of science who finally put the geocentric model to bed. And that, my friends, is something to truly orbit around. Let's not beat around the burning bush. The flat Earth theory is about as logical as a tetherball on a frictionless rope. But let's take a look at the facts. If the Earth were the center of the solar system, the planets would be doing the cha-cha-cha like a crazy disco ball. But when we make the sun the center, everything falls into place like a well-oiled machine. So let's all put on our dancing shoes and join the heliocentric solar system party, because the flat Earth theory is just too square. As you can see from these videos, the observed behavior of the planets in our solar system is much more consistent with the heliocentric model, in which the sun is at the center and all bodies orbit around it, rather than a geocentric model in which the Earth is at the center and all bodies orbit around this. The planets in the heliocentric model move in elliptical orbits, which can easily explain their observed behavior, such as retrograde motion. On the other hand, in a geocentric model, the planets would have to move in complex and convoluted orbits which would require a large number of small circular orbits moving around a larger circular orbit to explain their observed behavior. This heliocentric model is more parsimonious and is more in line with Occam's razors. So it's just elementary, my dear Watson. Now, I know some of y'all might be thinking, sure, the heliocentric model might be accurate when it comes to describing the motions of the planets, but that don't mean it's true. But let me ask you this. Have you ever seen the planets orbiting the Earth? Me neither. And that's because the overwhelming evidence in scientific experiments point to the heliocentric model being correct. Star trails are a beautiful and awe-inspiring sight that we can observe in the night sky. They are caused by the rotation of the Earth, which causes the stars to appear to move in circular patterns over time. As the Earth spins on its axis, the stars in the sky appear to move in an arc, with the North Pole, North Star, remaining relatively still. The longer the exposure of a photograph, the longer the star trails will appear. These trails can be seen as a representation of the Earth's rotation and provide evidence of our planet's spherical shape, as they would not be observed on a flat surface. And here's a little joke, anyways. Let me introduce you to Iron Horse, the ultimate hunter of muskrats. But as you can see in this video, as Iron Horse raises in elevation, he can spot those sneaky muskrats from miles away. Thanks to the curvature of the Earth, the higher the elevation, the further you can see around the curve. And as we all know, a curved Earth is much more parsimonious than a flat one. So next time you're out hunting muskrats, remember to bring Iron Horse and his laser eyes. Let's take some look at some drone footage here I'm showing. As a drone rises in altitude, notice how the ship on the horizon appears to become taller and narrower. This change in perspective can only be explained by the fact that we are viewing the ships from a curved surface. As we rise higher, we also see we are also moving further away. This explanation is simple, elegant, and undeniably true. Sure, the horizon looks flat, but that's just because the Earth's got a little curve to it, like a banana or Uranus. The only thing that's truly flat around here are my abs. And let's not forget, just because you can't see something doesn't mean it's not there. Like the back of my head when I'm doing crunches, it's invisible, but it's definitely there. I've heard many absurd claims to counter the heliocentric model, and here are some examples for your enjoyment. The idea that everyone has a personal sun is just ludicrous. I mean, can you imagine the energy bill for that? And the concept of the sun being an illusion, please. If that were the case, we wouldn't be able to feel the warmth on our skin or see the beautiful golden hues at sunrise and sunset. As for the idea of there being two suns, the one we all see and love, along with some mysterious black one that does who knows what, I can confidently say that I've never seen any evidence of a second shadowy sun in the sky. And finally, the idea that the sun is some sort of god named Helios is just plain silly. The sun is a massive ball of gas and plasma, not a divine being. But hey, to each their own, I guess. I would love to hear an explanation how any of these are possible. My personal work in remote locations where I rely on time synchronization via satellites in orbit and the theory of relativity to make the calculations for the time, the clock, is evidence of the accuracy of the heliocentric model, and I could not do my work that I perform every day if either were false. In conclusion, the evidence is clear, the science is sound, and it's time for the flat Earth conspiracy to be put to rest. The Earth is round, and it's time for us to embrace the truth and the beauty of our majestic, spherical planet that orbits around our single, glorious, life-giving sun.
A pear-shaped oblate spheroid.
So let's raise a glass, or should I say a globe, to the truth and the beauty of science. And that's all, folks. Thank you so much for listening, and go ahead.
You got it. Thank you very much for that opening, Ozien. And want to let you know, folks, if it's your first time here at Modern Day Debate, we are a neutral platform hosting debates on science, religion, and politics. I'm your host, James Coons, and want to let you know we hope you feel welcome, no matter what walk of life you're from, whether you believe in heliocentrism, geocentrism, you name it. We're glad you're here. And there are many juicy debates coming up, as you can see at the bottom right of your screen. Thrilled, we're going to have a juicy one on Is Christianity Rational? Between Stuart and Matt Dillahunty, as you can see at the bottom right of the screen. If you haven't yet, hit that subscribe button, as it's going to be a big one. You don't want to miss it. And with that, thanks very much, Iron Horse, for being with us as well. The floor is all yours for your opening statement. Let me just unmute you really quick.
Cheers, I got it. All right, thanks very much, James, and thank you, Ozien. That was a lovely, mild introduction. I found it hilarious, actually. I will get back to it later, of course, when we get on the open discussion, that gravity is like a tetherball rope. I mean, that's really a rope. That's great. Anyway, so we're talking about heliocentrism, and the nuts and bolts of it. Heliocentrism boils down to a very specific topic, which is that A, the Earth is a spinning oblate spheroid, and B, that it goes around the sun once a year. There's literally 10,000 ways in which I could dispute this not-so-ancient superstitious belief, but before I do, let's make no mistake about it. It is deeply rooted in ancient pagan beliefs, which in turn became strongly held religious beliefs, which, thanks to the back-engineering abilities of the governors of our minds, eventually led to the godless Big Bang theory of creation, which basically says everything is a result of a random, chaotic Big Bang destructive force which accidentally created everything from nothing, for no reason, without assistance, simply because the laws of infinite probability, or the mathematical theory thereof, says it's inevitable, eventually. We can skip forward a few billion years or whatever, and now suddenly the monkey, fish, frog, squirrel are dressed in togas and sandals and sending battalions of warriors off to foreign lands to steal their stuff they worked on to survive. And one of the old geezers says, "Hey, did you notice how that boat seems to vanish bottom first? And when we see it again, we see the sails again before the hull? By Jove," says another, I've even heard that beyond the horizon, they even see different stars. Let us appeal to our great philosophers to ponder how that could possibly be so. And one, the great mathematician Pythagoras, said, after great preponderance, "I have concluded that the sphere is the perfect shape. Every distance through the centre is equal, every distance from the centre is equal, and therefore, because our Creator God in heaven is perfect, and every heavenly light above seems perfectly spherical, then it stands to reason that we too must live on an almost perfectly spherical ball." Whilst Pythagoras merely hypothesized the Earth was spherical purely on aesthetic grounds, almost 2 centuries later, Aristotle based his belief on actual physical evidence, namely ships vanish hull first as they sail over the horizon, Earth casts a round shadow on the moon during a lunar eclipse, and different constellations are visible at different latitudes. It's almost as though we've taken a kindergarten grade level of understanding, dressed it up in purple, and paraded around as king. It's not hard to understand why the sun has been worshipped as a great deity from the beginning of the governing body, from the beginning of time, the governing body over day and night, the giver of life and light. As regular as clockwork, it's logical to understand why superstitious religious folks sought a scientific means by which to place it in the centre, the traditional place of worship. I could rant on and on for days giving a history lesson, but most everyone already knows about Zoroastrianism and how the sun is surrounded by his faithful 12 constant constellations, the 12 houses of the zodiac through which he passes annually. How the ancient northern European seers of old would dry out the red and white fly agaric mushrooms beneath the boughs of evergreen trees as the days got shorter and shorter, until finally, on the shortest day of the year, when the sun is killed by his evil brother Set, the seers would take the sacred mushrooms and astral travel, fly through the stars, to venture into the underworld beneath the horizon, and there in the stars see the great Southern Cross, the traditional marker of graves. And thus the story evolved that the Son of God dies on the cross, descends into the underworld for 3 days and nights, and on the 3rd day he is born again in accordance with the scriptures. There's even strong evidence to suggest that the sun was once known as Lucifer the light bearer, for what better represents the herald of the morning than the sun? Many try to argue that Venus is the so-called morning star, yet that really makes no sense, being that Venus is most always associated with goddesses, such as Isis or Aphrodite, and is often the first star to be seen in the evening. Nothing describes the morning better than the rising of the sun. Pardon me. While some rumours suggest a certain ancient Greek philosopher Aristarchus first proposed that a spherical Earth could be travelling around the sun, much like any other so-called wandering star, Even he allegedly dismissed the concept as absurd for many centuries. And for many centuries, the geocentric world was the accepted belief, hard to read my own writing, whereby the Earth was motionless, with the sun, moon, and stars moving around us exactly as we see and experience. Even when Copernicus reinvigorated the greatly debunked idea that the Earth was a planet revolving on its axis, going around the sun in 1543, he based it almost entirely on mathematical concepts and literally concluded it was impossible. I could basically sit here all day dropping names and experiments, searching for motion of the Earth throughout the centuries and modern times, but it becomes pretty obvious to anyone who's researched the matter that every single belief boils down to philosophical preference and the inability of so-called great men of science to accept the fact that Earth is actually the centre of existence. Even one of the modern heroes of recent science, Albert Einstein, came up with his famous theory of relativity simply because he couldn't observe any motion of the Earth. To quote, "Since then, I've come to believe that the motion of the Earth cannot be determined by any optical experiment, though the Earth is revolving around the sun." Here we may rightly invoke Hitchens' razor and say that which is believed without evidence may be dismissed without evidence. I actually find my mind boggling at the sheer amount of evidence I've uncovered over recent years that absolutely rules out the philosophical preference that supports heliocentrism over the obvious fact that our Earth is the only physical plane of existence fixed at the bottom of a mostly non-physical, electrical and sonoluminescent universe where, physically speaking, the sky truly is the limit. The big question always boils down to why. What purpose does it serve? And I think we could narrow it down to good old-fashioned human greed. Much like Iceland was named after ice for their enemies of the time, and Greenland was falsely named green despite being mostly frozen Iceland, it's proposed that the icy outreaches of the limits of our Earth were shrunk into a tiny continent and claimed to be the southernmost limits of a ball-shaped planet spinning in space since the law... pardon me. Spinning in space. Full stop. Since the law of the sea differs from most laws of the land, but the law of karma is basically the law of cause and effect, then it is only by our consent that we allow another to rule over us, to govern us, to force our children into compulsory government-approved education, all based on the tradition of maritime law, whereby anything found lost at sea becomes the rightful property of he who discovers it. So when Vatican-inspired Jesuit priests conveniently discovered Earth to be lost, floating in the galactic sea, they legally claimed lawful possession of all its land and wealth and all living creatures as their livestock. Slavery was never abolished. It simply became far more profitable to let them think they were free, make them pay for all their own food, accommodation, clothing, etc., and force them to pay for their own masters and protection, the policy enforcers, and threaten everyone with fines or imprisonment if they refuse to pay taxes. Basically, by having more land reputed to have great wealth and advanced technology, introducing and maintaining scarcity, the very private and discreet ruling class do very well for themselves, giving us the illusion of choice, selecting our own pre-selected puppets and media circus, while we, by consent and the art of letting he who will be fooled, and the traditional act of consent, whereby our parents willfully sign over our certificate of manifest to the registered corpse oration at our moment of birthing from the waters onto dry land via the dock, serve out our duty on the citizen ship. If I may now end with a few final words on the impossibility of the heliocentric idea that the Earth goes around the sun. I know my opponent Ozien heard my introduction just 2 weeks ago, whereby I described a scenario that makes the moon impossible if it's to orbit us exactly as we observe, but assume the Earth to be in orbit at 66,600 miles per hour around the sun. That's even if we assume the sun to be motionless, as Copernicus proposed almost 500 years ago, as opposed to today's astrophysicists who tell us the sun is actually in motion over 500,000 miles an hour in yet another direction. The act of any body orbiting another body in motion is mathematically proven to be impossible. Again, we may dismiss the belief which has no evidence. Finally, I'd like to finish on a point that is constantly glossed over by the helioists and handwave dismissed without giving it due consideration that it truly deserves, and that is the clock. This point absolutely destroys heliocentrism for anyone with enough working brain capacity to understand it. For if we think of the sun as the hour hand of a 24-hour clock, it makes perfect sense that it returns overhead every day in every time zone, more or less at midday, with just slight seasonal variations. However, this is a problem for anyone of a mathematical mindset capable of understanding things from an engineering point of view. For if the Earth itself spins on its own axis to create a period of time we call day and night, and we measure this very precisely with a clock, as we do in all four corners of the world, but we say that the period of time given as a year is us actually orbiting the sun, then it's logically impossible to measure the same amount of time, regardless of which values you manufacture for it, and have a fixed clock still match the midday overhead sun each day. It just doesn't work. Without adjusting the fixed time measurement of a clock by as much as 4 minutes every day, in 1 week, the sun will be out of reckoning by half an hour. In 3 months, midday by the clock will be at sunset, and in 6 months at midnight. There's simply no logical way out of the argument. The only way it could work is if we measured time by sundial, but with a physical fixed mechanical clock only means a fixed timepiece for that matter. The geocentric Earth manages this problem beautifully, logically, and sanely. A sidereal day tells us that it's the stars themselves rotating separately as a single body, almost 4 minutes faster than the sun each day, as the sun remains precisely 24 hours every day going around above us. And that way, over a period of 28 to 29-day moon cycle, the sun then seems to be rising in a different house of the zodiac. Thus, one of the oldest of sciences, astrology, is based on logical observations of the sky clock above us. So not only is the sun itself proof of our geostationary, non-heliocentric model, even the stars support presenting precisely the same constant constellations year after year, century after century. The fact they return precisely to their starting point approximately 365.25 rotations of the sun later shows us that there are greater repeating cycles going on above us. So basing them all entirely upon the sun, Helios, and thus heliocentrism, is entirely a false made-up belief. The stationary topographical planar Earth fixed at the bottom of the known observable universe is the only logical conclusion any rational mind must eventually accept.
Thank you very much for that opening as well. And want to let you know, folks, we're going to jump into the open dialogue in just a moment. Couple of quick housekeeping things. In particular, if you happen to have a question, you can feel free to fire it into the old live chat. If you tag me with @ModernDayDebate, or if you use a super chat, those go to the top of the list. As well as, if you didn't know about this, we have expanded onto TikTok. Once we get to 1,000 followers on TikTok, we will be able to live stream our debates there, which we're excited about, as we really do want to provide a neutral platform across the different social media platforms for debate. As you can see at the bottom right of your screen, our link for our TikTok is both in the description box and pinned at the top of the chat. So if you help us by following us there, once we get to 1,000, as I said, we'll be able to expand our live debates there as well. With that, thank you very much, gentlemen. The floor is all yours for open dialogue.
Go ahead, Tony.
All right, so let's go to clocks, right? So the work I do commission for substations, which requires from terminals that could be 100 miles apart. And we send a AC signal. It's a 60 hertz. If you're all familiar with it, it doesn't matter too much. But we have to synchronize our test sets at 2 locations perfectly. That requires us to have line of sight of at least 4 satellites in orbit so we get a signal. So if I have my antenna too close to the building, doesn't have line of sight of satellites in orbit, I won't see enough satellites to get a good signal for my test set to synchronize my clock. And in this case, a clock just means like an oscillator, right? Not like a 24-hour clock you would think of normally. So we have to do that at 2 ends, and they have to be synchronized almost perfectly to like less than a millisecond synchronize. And you can't do that just setting a clock. You can't synchronize them that closely. And the work I do wouldn't work unless that was precise. So how would I be able to do my work if there weren't satellites in orbit? And I also have to use theory of relativity, because we have to compensate for where the satellite is, the distance between the 2 satellites and us, and the gravity between the 2. So how would I do my work if that didn't work?
Yeah, well, you've sort of brought up a separate topic altogether from clocks by saying that you're using a different sort of clock, not the 24-hour clock, whereas I based my argument on the 24-hour clock, the same one that everybody uses. Yeah, so this one, you're saying satellites exist, whereas I say that satellites, according to the heliocentric model, absolutely cannot exist, because it's It's ludicrous to think that the Earth itself could be hurtling through the universe in an almost linear direction. It's less than a degree per day, so you could may as well call it linear, of about 1.6 million miles every single day, which means that the satellites going around us must be also going that speed. Like even things like the International Space Station, the ISS, is going 17,500 miles per hour. How is that possibly keeping up with the Earth going 66,600 miles per hour? And while we're chasing the sun going 514,000 miles an hour, that's over 500,000. So every one of these little satellites that you're believing in, according to the heliocentric point of view, must be going all those speeds, plus then some other its own speed to stay basically geostationary relative to the Earth. It's impossible. The only way that could actually work in reality is the geostationary Earth, and we send weather balloons up with things attached to them. They could stay geostationary without having to invoke all these amazing, impossible speeds that just they can't work for an inanimate body that has no means of thrusting. It's trying to thrust through a vacuum. It's impossible to do. It just, there could be things up there for sure. Absolutely. I believe that. And there could be technology up there, but it is not working according to the heliocentric model as you believe it. It would be impossible.
Gravity has to exist for me to be able to get the correct time. So
Gravity,
it has
but
to
you
exist,
said
or I couldn't
like
get the correct time.
It's like the tether of a tether ball.
That's analogical. So I was given an analogy. That's not what gravity actually is, right? You're familiar with theory of relativity.
It's a very poor analogy, though, if you have to invoke a physical tether to try and provide some sort of means to provide,
okay,
an
but let's go.
That has no physical tether whatsoever.
Well, it is a physical tether. It's all physical. So it's not like a phone physical, right? But it's physical in the sense that it's a physical like force that interacts between physical objects that cause them to I want to say attract, but I'm not a physicist, by the way. But anyways, so it's a gravitational constant times the mass of the two objects times each other divided by the distance between the two objects squared, right? So the radius squared. Anyway, so that has to exist for me to be able to calculate the proper time at my two locations. So even if you say they're weather balloons, like somehow they go up high enough for these calculations to work, gravity has to exist for me to get the correct time at two locations. So we can go to the 24-hour clock thing and why we have that 4-minute difference every day and how we compensate for that. As I'm sure you know how we compensate for that. But I just want to know, I know from personal experience, the work that I do, gravity has to exist. Satellites have to be in orbit. The sky isn't big enough for where I have to see. So let's say I'm like 100 miles apart, right? So anyways.
Yeah, this whole idea of gravity, of course you need it to exist, but there's absolutely no evidence of it. Nobody has ever proven it.
I do my work.
It's a very, very poor theory. Every scientist admits it's a poor theory and that there is no evidence for it.
I can't get a synchronizing time. I can't get a synchronizing time at two locations if gravity doesn't exist.
I fail to see where your argument makes any sense. Like, we know for a fact that nearly everything that we call by brand name a satellite signal is just something that comes from some sort of tower. It's all radio signal. There's, of course, modern upgraded 1G, 3G, 4G, 5G, the whole works. We've got all these different signals as well. But there's no
How's
way
the tower held up?
None of this could possibly work if the Earth is moving the speeds that you think it is, and you think that gravity is a force of attraction. A force of attraction causes things to collide and crash into things. It does not cause them to perpetually remain in motion at ridiculous speeds, whether they be in front of us, behind us, beside us. It means they're speeding up, slowing down, changing speeds all the time, as I described basically in the last debate, which you obviously heard because you put in plenty of super chats. So you heard how I described how impossible the moon is according to the heliocentric model, but you believe all these satellites are also doing the same sort of ridiculous speeds. They cannot possibly do it, and especially not if you're invoking a force of attraction known as gravity. It just can't happen.
So everybody sees and experiences gravity every day. It does cause things to attract and come together. So the planets in orbits around sun. So it's like I know you might, yeah, I know you deny it, but anyway. So we got comets and stuff. You can see them during certain parts of the year. Every so many year, they come in a pretty on schedule, right? Same sort of periods of time, and those go. They have a very long elliptical orbit because they are falling into the sun, right? But they're going fast enough that they escape the gravity of the sun and they can go back out and they stay in that elliptical orbit around the sun. So they do fall into each other because of gravity. I mean, that's how gravity works. So and
seems to me like you just have to have this gravity. You've got no proof of it, and yet it can't work according to the way you've described it, because that's what I've already described to you. You know, come on. I've been quietly sitting while you're talking. We're trying to be polite here. So in your belief, the heliocentric model has the sun moving 514,000 miles per hour through the galaxy. Now, that is a ridiculously fast speed. The Earth itself is only going 66,600 miles per hour around the sun, which means it's moving a sidereal speed as well of the same as the sun. And so all of these satellites are also doing the same thing. And comets. So these comets that you're saying, how many millions of miles away are they? Also following the gravity of the sun. Any example we see of gravity, you see the scientists do it all the time with their sheets, lycra material and stuff. Everything just crashes into the center after just a few rotations. There's no way that everything could stay in this perpetual motion of the incredible speeds that you are proposing and still logically work. Everything is completely illogical, and it seems to me like you're just lacking a little bit of something upstairs to not grasp how that couldn't possibly work, because multiple speeds, different directions, one thing going one speed, one direction, doesn't work. It has to go all those speeds all the time.
Yeah, the analogies we do on Earth, where you spin the ball around like a sheet or whatever they do, like you're describing, that's just an analogy of how gravity works. It's not actually how it works. They're just trying to present a representation to students. See, it works sort of like this, right? So, and I'm not an expert. I'm sure people in chat can explain it all, but that's beside the point. But all those bodies are staying. I say tethered. Tether is not a right word. It's just an analogy. It is a force that keeps the planets in orbit around the sun, keeps the moon in orbit around us, keeps the satellites in orbit around the Earth. These numbers sound huge because we're used to going speeds like a few hundred miles an hour at the most, right? Like in a plane, we might go 500 miles per hour or something like that. So these numbers sound absurd, but that's only to our frame of reference. When you look at the speed that the sun is rotating around in the spiral arm around the galaxy, it's not very fast for the sun, like in comparison to the galaxy.
Yeah, look, you invoke a lot of like fanciful terms, and I know you're not alone like that, and fair enough, you admit you don't know what you don't know, and I appreciate that. And I would also think that a lot of people in the chat don't know what they don't know either. So to invoke a term like frames of reference, it makes it sound a little bit scientific-y and stuff. But when it comes down to logic, the nuts and bolts of understanding a real speed, not a relative speed, there's no such thing really as a relative speed. Like, yes, relative to you, something might be moving while you're staying the same speed as the plane. That's about all. But when we talk about real speeds, like the real speed of what the Earth is supposed to be moving around the sun, why does the plane never, ever take into consideration any of that speed? Like, anytime we shot off a rocket to the moon, for example, and the Earth is just shooting off through space at 66,600 miles per hour, that rocket is never going to reach that speed to return to Earth again. We've automatically left it the moment it leaves the frame of reference, which you claim everything has, is inertia. But every example we see of inertia on Earth, if we jumped from the plane, for example, within seconds, we've stopped moving the speed of the plane. We're no longer going that speed. So we'd start dropping straight away. Anything that leaves, if you jump off a speeding train, you stop moving that speed. So to say that relative speed and inertia works somehow in your vacuum of space, it's so much easier to just believe what is obvious and what is true, and that is that the Earth isn't moving, and the plane can fly 500 miles per hour and travel 500 miles an hour because the Earth isn't moving beneath it. It's as simple as that. You keep invoking too many false things to have to stick to your belief. But, if a plane took off the Earth and it's traveling towards the west, then the Earth is spinning 1,000 miles an hour beneath it. So it's traveling 1,500 miles an hour to the west. But no, it's traveling backwards 500 miles an hour to create the illusion of moving towards 500 miles an hour. It's ridiculous. Why not just say it's moving 500 miles per hour while the Earth stays still beneath it? That works. We don't need to invoke silly nonsense ideas to defend a silly, ancient, superstitious belief that says that we're going around the sun when we're obviously not.
Yeah, we do normally maintain the frame of reference of the Earth for the plane. So we don't see the planes going backwards and forward. We see how fast it's going forward in reference to the Earth, right? So we do that. But if you do invoke like the rotation of the Earth, then you can add that speed into the calculation. So the Earth is spinning with the planet, and all the air is spinning with the planet too. The plane takes off, goes in that direction. You can do it that way. I don't think it's very useful in day-to-day life to do that. I don't do that in my day-to-day life. I go 60 miles per hour. I don't take into account how fast the sun orbits the galaxy, center of the galaxy. I mean, I don't do that, but those numbers are there and they exist. But it's just not a belief. It's stuff I do every day for work. Gravity has to exist. You brought up a point about towers earlier, that these things could be up on towers. There's no tower above me. Like, it had to be like right above me on the building, like that I can't see it. Like, unless there's invisible towers holding satellites up in orbit, in geostationary orbit, I could not do my tests. They have to exist.
Yes, well, obviously, you can listen to your radio in the car without having to see the tower where the radio transmission is coming from. Air waves propagate through the air in a much different way than, say, how water waves propagate across water. Water waves actually require flat water for a water wave to work. So, again, that just automatically destroys any idea of being on a spinning space ball, the fact we have water waves. But air waves are completely different. They can travel vast distances. I've even sat and listened to a guy from Newcastle, Australia, basically communicating directly to Hawaii on a backyard ham radio with a single antenna, maybe 3 times the size of a normal car antenna. It wasn't huge. It was just a very basic sort of setup, illegal, by the way, but he was able to contact Hawaii. Now, that tells me that the radio waves have this ability to travel great distances. You don't need to have line of sight of the tower for the radio wave to actually work. The glober will try and tell us how it's bouncing off the ionosphere and bouncing off the surface and doing all this sort of stuff. But that's what you have to bring up, these sort of weird excuses, whereas you can have these towers pinging out signals for doing exactly what you say you were doing. You haven't really even made that clear exactly what you're doing, why you need these satellites at this stage. But I can tell just by GPS alone that the GPS signal works by being able to detect various signals bounced off of radio towers, picked up by the phone or the GPS device, and computed onto a map, which can give you a very accurate description of exactly where you are. And that's pretty much what I think is all you're doing, is you're working off a very similar thing. It only requires radio waves. It does not require satellites, which, as I've said, like, they can't exist. They just simply can't exist in your belief. They're going too many different speeds at once in order to somehow remain very specific and geocentric. It's just impossible. So, what exactly is your work that you say you're doing that gets these signals from satellites that you're talking about?
So it's telecommunication equipment. So we inject current at 2 ends, and then we send a light signal through fiber cable between the 2 ends, and they have to be synchronized at the same moment, because we have to be able to trip our breakers open, those big, huge, giant circuit breakers you see in substations where the power companies are. You have to trip open within 5 cycles of each other. So you can have a 100-mile line, both ends. There's other ways to see the fault, but differential protection is the fastest that we use, and it has to be precise. But I do want to address the thing about wave propagation that you brought up. So you said, like, waves don't propagate through water. They do propagate through water. Even if the water's rough, You just don't see them, but those forces do propagate through the water, and it mixes with all the other ripples in the water. So you may not see that nice, pretty wave like you see in a calm body of water when you throw a rock into it. But those ripples of that wave do propagate through the water. But that is different from radio waves, right? So RF is like radio, or it's its own thing. It's electromagnetic force, right, that propagates through the atmosphere, and it does travel line of sight, right? So you can send it broadly. And microwaves are a good one. Like microwaves are higher frequencies. They don't skip. Like you can't send a microwave signal over the curve, right? So you have to have line of sight. There are some exceptions to that where there's some, I think there's some, like one exception where it's like, maybe it's like low. I can't remember. Anyways, microwaves have to have line of sight, and they are radios. It's things like your ham radio. So I didn't use ham radios. My dad used to use ham radios. I won't say if he was doing it legal or not. I'm sure he was not. But those skips that we're talking about, where the radio waves skipping off the ionosphere, you can calculate based on solar activity, based on the time of year, how far that signal could travel. Like we talked to people from Australia, in Washington or Oregon, wherever we were at the time. And it was only during certain times of the year, during certain type of solar and stuff like that, certain times of the day too, because you can get more propagation skip at night than you can during the day. So, yeah.
Yeah, well, I think you've just basically debunked the fact that the Earth could be a globe then, haven't you? Because you said they need a line of sight to propagate. And then you've also just turned around
microwaves.
And said that these satellite images you use are through wires on Earth. I mean, it's well known that nearly all of the internet communication across Earth, 95% plus of it, is done through undersea cables. That's how we're communicating right here and now. So the say that you even
we
need
use
to
radios.
Use we're using radios now. I thought we were talking about your job.
We can.
Like you said, you've sent light signals through cables. So, you know, your story's all over the place, as you'd expect from anybody that's confused about the way they talk about things. And as I said, with water waves, is that they can only propagate across flat water, even if the water is rough and bumpy and already rough. They're not going to propagate across curved water. And with 70% of the surface of the known Earth being curved, according to you guys, curved oceans, which is just a ridiculous concept that water could even do that in the first place. The fact that you can have a wave going over curved water, the wave would flatten it in the first place. So all land must be measured above sea level to begin with. So that's how we know that the Earth is flat. We know it's stationary by the fact we see the same stars going around all the time. We know that the sun moves exactly 24 hours in every cycle. You haven't even addressed that yet, because that's what matches our clocks. You know, the sidereal day is not what we set our clocks to. It's the sun. And you're still just clinging on to satellites for some reason. So, you know,
well, we can move on to clocks.
If you looked at the other day talking about satellites, that proves we're on a spinning space ball or something. I tried listening to that one with my son, and we were just cracking up laughing. And he's not even a flat earther.
Well, we can move on to clocks, but I just want to point out, like my work I do, we do have to see the satellites to synchronize when we send the signals. So we need a time clock synchronized, send signals, and those signals have to match. The times have to match for us to know what the power is at both terminals to be able to protect the line. So I don't want to go into all the math involved. It's not that important, but it is two things we're doing. Just make that clear. But let's move on to the 24-hour clock, right? So you say we lose 4 minutes a day. So that's sort of an average, right? So, but it is a case that not every day is we're losing 4 minutes. Some days are over 24 hours. Some days are less than 24 hours, right? So on average, we're losing 4 minutes a day.
No, if we were going around the sun, this is very specific. So the sun is at the center. And so therefore we're making a circle, our annual orbit around the sun. So if the Earth itself is spinning at a very specific set amount of time, and each time it moves a little bit further around the sun, 365 and a quarter of them, then it will be out of reckoning to the sun by 4 minutes per day. So there's no other way around it. This is a logical, mathematical engineering problem whereby anything measured at exactly 24 hours each single time going around a center point will be out of reckoning by it. Now, if we didn't use the clock, as I said, if we just stuck to the sundial, it could work. But we use very specific, very exact measurements, clocks, watches, digital watches, the whole lot, 24 hours every single day. So the only way that can work is if it's the sun itself moving around above us and returning back 24 hours. Now, you can give or take a little bit because we know that over the period of time the sun gets higher. To give the summer in the inner hemisphere of our Earth model, it goes around the equator. As it gets higher, it seems to make a smaller circle. So as it comes lower, it seems to make a bigger circle, but it still takes exactly 24 hours to go around us each and every time. And that's what we set our clocks to. So if we were going around the sun, we'd have to adjust our clocks by 4 minutes every day, regardless, to keep the sun overhead every time because, obviously midday is looking towards the sun in the center, midnight is looking away from it outwards. So without adjusting the clock, it just doesn't work. It has to be.
The length of the day does get longer and shorter the year progresses, right? So the length is sunlight and night. Yeah, so the length of the number of minutes during the day is not always 4 minutes less. It's like something like 23 hours, 56 minutes, and some odd seconds, actually, on average. But some of those are over 24 hours. Some of them are less than 23 hours and 56 minutes. So the average is 23 hours and 56 minutes. And so the Earth is in elliptical orbit, like you sort of described.
We're not talking about daylight hours. The daylight hours is on average 12 hours. In less,
I'm progressed.
More. Okay, but to then try and put this to a 23 or 24-hour timepiece, it's got nothing to do with the length of daylight hours. It's got to do with the exact length of period of time between midday one day and midday the next day, and that's exactly 24 hours. And so if we are traveling according to a clock around the sun, then we are out by 4 minutes every day. There's no plus or minus. It's just, plus or minus a few seconds, but it is the exact same amount every single time because we measure the exact period of time by the clock every day.
Our clocks aren't, they're 24-hour clocks, right? And they match the orbit of the Earth, right? And we lose 4 minutes a day because we're not precise. They should be 23 hours and 56. Well, they shouldn't be 23 hours and 56 minutes. Otherwise, the when daylight would happen would change if we didn't have the clocks that we did, right?
That's the whole point of my argument. Obviously, you can't quite grasp it. I've tried to describe it as simply as I can. That if we
let's break it down.
The clock needs to be adjusted by 4 minutes per day to keep the sun overhead at midday. It is an inescapable logical conclusion that anybody with the ability to think about it can understand. But the fact that we measure it exactly 24 hours every single day can only be because it's the sun moving around above us. It's the only way it works.
Why do we add an extra day every 4 years to our calendar?
Because the number of rotations of the sun matching the number of rotations of the sidereal day, which is the stars, before the stars to return back to exactly their starting period is 365.25 rotations of the sun. It's not quite exact, of course, but it's more or less. So every 4 years, if we add an extra day to the calendar, which is what we judge our sidereal year by, the solar year, so the sun spiraling up, spiraling down with two equinoxes in the middle, it keeps those days, according to our calendar, on the same day, more or less, every year, if we add that extra day every 4 years, because it's the stars in motion that give us the sidereal day and sidereal year. Whereas if we just did it off the sun, we might just count 360 and assume, that's close enough, we'll just call it that. But then our calendars won't match. The equinoxes and solstices will always be different. But because we measure it, the sun compared to the stars, but by the time the stars return to exactly where they were, the previous year, there's a quarter of a day's difference. So the sun and the stars don't exactly match. So that is why every 4 years we will add an extra day to our calendar so that they stay the same over a long
except
period.
Except every 100 years. Well, except every 100 years. It's every 400 years we add it, right? I think every 400 years we add it.
We skip one.
We skip every 100 years we skip one. I thought. Anyways, it doesn't matter. I forget.
That's right. It's
I'll just take it. But it is 4. So if you take 4 minutes times the number of days in the year times 4, that equals 24 hours.
That's right.
Roughly. Yeah. 4 minutes. That's 4 minutes you're talking about. That's the leap year.
That's right. That's why
adjust every 4 years.
We're looking at the sun today, right? Like, let's just use today as our arbitrary example. We're looking at the sun at midday. So that would mean that after 365 and a quarter rotations, we'd be looking at the sun at midday again if we are traveling exactly 24 hours on each rotation around the sun. But because it's the sun going around above us, it matches every day of the year. We don't have to wait 365 and a quarter rotations to have it back overhead every day.
All right. So to me, it's a leap year. That's how we account for the extra 4 minutes. So anyways, and it's not changing
I know that's the trouble is, as I said in my opening statement, is that most people gloss over it because it's a little bit too complicated to actually understand how it would in fact actually work. Whereas if you just look purely at the logic,
I understand,
and put the sun in the middle, stationary, like assume it's not moving, and put the Earth moving around its axis to go around the sun with 365 and a quarter rotations, then every single day, if you measure an exact period of time, the sun would be slightly out of reckoning, which is why day and night would swap places after 6 months, because we're using an exact fixed clock. Now, if we didn't use an exact fixed clock, and we just use the sundial and the clock's automatically adjusted by that 4 minutes every day, then it would work to have the sun appearing overhead. But that in itself destroys heliocentrism, which is the point of this debate. And I think I can just rest my case on that.
The clock would just be whatever the rotation of the Earth is. That's it. But anyways, your seasons would get off. You have to adjust for seasons and everything else. But you know that.
Would.
Like, we've been doing this for thousands of years.
We keep the clock at 24 hours every day. We don't adjust it.
Well, we have hour-long days. I mean, we just arbitrarily choose it because it's like our cycle, the diurnal cycle we live in. But I do have go back
Sure.
So, like, my view is that there's one sun. Like, we orbit one sun, right? So how many suns are there in your model? Or in your concept of reality?
In my concept of reality, that's a better way of putting it. Because the fact is, when we do see the sun, what we're looking at is our apparent version of it. You can tell this simply by, say, if you're watching a sunset and you walked along the beach, the sun will move with you, as will the reflection of the sun move with you as you move. So you can extrapolate from that say there's 50 other people all stretched out across the beach. They're all looking out at their own personal reflection of the sun coming across the water. So they're seeing the sun in a different spot. So you could then also extrapolate then that if hypothetically there was a different person every single spot right across the entire beach, or the entire continent, as far as you want, there would be an individual sun with an individual reflection for each and every one of them. And if it's just one sun, of course, we're all seeing the same sun, but we're all seeing our own version of it doing something completely different. I don't see the sunlight reflecting to their feet, someone 200 meters down the beach. I see it reflecting to my feet. But technically then, the whole water is lit up by the same sunlight reflecting across it, but I don't see that. So that's why I say we see our own version of the sun, and therefore there must be as many versions of the sun at any given time as there are people with eyes or plants with feelings that can feel the sunlight, anything that can perceive the sunlight. That's how many versions of the sun there are at any given time. And you can't pinpoint it down to just one. The minute you do, you're wrong, because if I could travel instantaneously really, really fast and go 500 miles away. So I'm watching sunset happening here, and then boom, or say someone's got a webcam going. they're watching it there. We're seeing the same sun in two completely different locations. Now, this is the biggest mistake that we've made throughout history, is that we're assuming it's the same sun in the same spot. So if we try and triangulate to that sun, it's going to tell us that it's an infinite distance away, like 93 million miles or something. Whereas in reality, it might just be a hot spot in our firmament, just 70 miles high. But because we see our unique perspective of it in a line of sight, it could actually be thousands and thousands of miles away. We're just seeing a different version of it to our unique point of view. So that's why I say, it is definitely a very subjective thing. And to try and extrapolate facts to say this is exactly how far away it is, it's always going to be wrong. There's nothing we can do about it. It's just the way it is. It's the way we see it.
So I understand, like, we can only experience reality through our own subjective experience, but I would say there's a distinction between my experience of reality and what is real, right? So I might experience false things. To me, there's one sun. And I do agree, we all experience everything differently in our own unique ways. But I wouldn't say that everybody has a different sun at all. I mean, to me, that doesn't make sense. But I can understand how you could I don't understand it. Actually, it's not the way I think. But what about other claims? Do you think everything is? Do you think everything's true that people experience? Like, is it true because they experience it?
Well, it's true to us. Like, the person experiencing the thing, for them, it is true. But we can't base all of reality upon our own personal experience of it. We have to understand that there is that many different versions of it. And each and every one of them is unique, and it is special, for want of a better word. We can't say that ours is more correct than another's, but when it comes down to scientific observations of things, that is exactly what they're doing. They're saying, right, I'm setting up this equipment, I'm taking this observation, this is reality, this is what's happening. Whereas a person, as I say, 500 miles away might be seeing a completely other version of the same reality, but it's different. And you can't put the two together and say they are the same reality. They're different versions of reality. And that's pretty much one of the most profound things about our reality we live in, and why people will come up with ideas like maybe we live in a simulation, because in a sense, everything that we only experience within. And quite a lot
realism.
Of the philosophical masters over the history of time have all said everything is within. And I can understand where they're coming from. That what we think is without, we only see within. If we lost our senses, it wouldn't exist to us.
Yeah, I believe in indirect realism. I don't believe I experience reality directly. I think it gets translated by my brain before I experience it in another part of my brain, basically. But that is sort of what we tried to do. Like we said, well, everybody's experiencing things differently. So how can we determine if what your experience is true and what you are experiencing is true? How can we remove that subjective lens to try to figure out what is objective about reality, right? So that is what we try to do with science. We try to create an objective standard to try to remove as much of that subjective experience of reality from our knowledge as possible. Now, it's unavoidable that all of our knowledge, even the knowledge we perceive, by Neil deGrasse Tyson, I did that little thing, is through our own personal experience, right? But the knowledge we're gaining is we're trying our best to create objective standards for knowledge, right? And I live my life as if those objective standards work, and I'm able to do my job, my work, because electricity works a certain way, radio communication stuff works a certain way, electronic devices work a certain way, gravity works a certain way. Just it has to. Now, maybe that's how I'm experiencing my life, right? Maybe I'm delusional, but I don't think I am. I think most of the people around me experience the same thing I do, and they look at the same results I do, and they're drawing the similar conclusions that I do. And not many people draw the conclusions that you are. It used to be like, what is it, like, there's direct realists that believe everything they experience is absolutely true. They don't believe the see anything through some type of process in their mind. And there's idealists that think all thoughts and stuff have some ontological significance or something. I'm not a philosopher, beside the point. But I don't think that's true. I believe everything is physical. It's what I experience. I stick my hand in a fire and know how much I want to not feel the burn when I stick my hand in the fire. My hand burns, right?
That's an interesting thing you bring up. Do you think fire is physical?
Yes.
Okay. That's one of those ones I'm a little bit confused about. I don't know if it's physical or chemical or something in between.
Well,
yeah.
Well, we're muddy with the language, right? When we talk about physical and everything, we're very muddy. So to me, physical is just like the laws of physics govern how those interactions work and the excitation of the molecules, right? That's how you feel heat. Is it excites the molecules in your hand and causes them to heat up, right, and burn and whatever. I'm not an expert either on that, but
that's like just about anything could come down to then being a philosophical preference or how we prefer to believe. Some people might say it's just the nerve endings picking up the sensation of heat causing the physical pain, and I think that's one of the ways that we do understand reality is through physical sensations, whether it be through pain or joy or whatever we're looking out at. But at the end of the day, really it all does boil down into what you see is what you get. And obviously colour doesn't exist to a blind man, so it's a bit silly to talk about a red sunset to somebody who's never seen colour, for example. You just can't explain the colour red. You have to experience it. So life is basically experiential things. And to try and rope this all back to our topic of this debate is that heliocentrism just seems completely illogical. It doesn't add up in any sense. We've got no sensation of the motion of the Earth, no sensation of it spinning around. I used to watch a lot of sunsets when I was younger. I was a very sort of spiritual type of guy. As a teenager, I'd go out watching sunsets all the time. And I used to sit on top of the sandhill watching the sunset and physically believe I was feeling the motion of the Earth spinning away towards the east to create the illusion of the sun setting. I fully believed that stuff. That was my sense of existence on this magical little blue ball in this Goldilocks zone going around the sun. So for me to eventually come to the conclusion that that was all nonsense, it was just something in my head, it literally is what it was. You can believe whatever you want, and it might seem real at the time. But as soon as you come to the understanding that the Earth is stationary, that water seeks its level, all land is measured above sea level, then it makes sense that we are not on a spinning ball going around the sun. And that is why, for example, every night of the year, I can look out my door and I can see the constellation of the Southern Cross. I can see it every night of the year. So if I was on the other side of the sun 6 months later, looking out at completely different stars, I should not be seeing the same constellations at all, but I do. I see it every night of the year. I did it 3 years in a row once I became aware of the flat Earth. I can see the Southern Cross, and I'm not far enough south.
Can you see the Northern Star?
No. You showed an example of the star trails from the Earth's point of view. Now, as far south as Australia is, it's not that far south. We're not far enough south to see perfect star trails around the pole. The pole's way down there, for example. We should be looking out and seeing all the stars doing exactly as you showed in your diagram, rising in the east and setting in the west. But they don't do that. So, no, I can't see the northern pole star at all. That's how the world was calculated in the first place, that where the equator is, that's the equidistant point away from Polaris that it merges into the convergence point. And that's how we drew our maps. So we navigated by the stars. So the equator becomes that point. So everything beyond that point is what we call that underworld, the outer world. South, sail outwards becomes southwards. That's all it is. We've got inwards and outwards. Has never been proven to be as a result of curvature. Everything with distance gets lower and lower as you get further away from it. So as you measure Polaris getting lower and lower, that's where our latitude lines were drawn. And they used a compass on the map. They drew a circle on the map. It's all done in circles, bigger and bigger ones, until we get to the equator, and then it suddenly goes pear-shaped.
We weren't that good at navigation before we developed better maps, right? Before we understood that the Earth was curved, right? So we could navigate the globe, like, you know,
I don't know
Columbus
about
was
that.
wrong too. People always say, I was the sailor too, like you brought up.
There's a lot of evidence
Yeah.
of there's even like Egyptian hieroglyphs here in Australia.
I do want to ask
way
you a
before
question. I
Australia
ask
was
a
even
question.
discovered. So we've been navigating the Earth for a very, very long time, and it's got nothing to
Well,
do
they
with.
might not have been navigating the globe, they navigating around the area. Like, how far away did the Egyptians go? But I do want to have a question, right?
Sure.
Where is the center of the Earth?
The center of the Earth would be what I'd call the magnetic North Pole.
How do you know that's the center?
Well, all compasses point towards it, and so we've just drawn our maps in accordance to that. I mean, it doesn't mean it's the center, it's just the way that we've worked it out over the centuries, that in a way that works for us logically, how to draw maps, is that if the magnet points towards the inside, that's north. If it's pointing outwards, that's southwards. And east and west are just bigger and bigger circles the further outwards we go.
But don't the star trails don't match the magnetic north, though, right?
The star trails are definitely an interesting conundrum when it comes to the outer side of the equator. Like, I won't deny that, but I've never seen what people say that we're seeing is seeing them going around a center point, for one thing.
Yeah.
You know, like we see them.
But if you go to the north,
so
if you go to the North Pole, it should see.
Yeah. So it all works in the north perfectly fine. As soon as we get to the outer side of the equator, that's where things, as Neil deGrasse Tyson says, go pear-shaped. But basically,
a pear-shaped oblate spheroid.
Where we see the Southern Cross in Australia, you know, it's daytime over in South America or in South Africa. It's only just at the very dawn of Western Australia, so it's becoming light. We stop seeing it, that the people in South Africa start to see the Southern Cross. So it's exactly how we see the same sun for daytime, we see the same stars at night time, but we don't see them through the day. And that still works as if they're all going around Polaris. It looks different because we've basically turned around and we're looking the other way. It's the only way I can describe it.
So we know where the magnetic north is, right? So it's 1,200 miles from where the center of the star trails would be for the northern pole, right? So the way the star trails would look is going to be different at magnetic north than it would be at where the star trails would look like a great circle straight above you, right?
Yeah,
like
I can't make sense of that actually, even on the globe model. Like, how do people say, let's just say 45 degrees south, so if the equator is 90 degrees, or is it the other way around? The pole is 90 degrees, the equator is 0. So if we said about 45 degrees, how is it then, by aligning a camera to the North Pole, that even the stars do make perfect circles? It doesn't sort of add up to me. You'd have to be pretty much within the Arctic Circle for star trails to work according to the globe model. So to me,
you'd have to go to the North Pole.
The globe don't work. You'd have to be at the pole nearly, or just, you know, as far as Finland maybe. But you get all the way down to, say, I don't know, say Japan.
But there's people that've been to the North Pole.
It doesn't seem to work.
People have been to the North Pole, right? So
yeah. Like
okay.
Perfect star trails from the North Pole absolutely should work, according to the globe. But the further and further south you go towards the equator, the less circular they should look. They should be looking more and more.
They do.
Big egg shape.
Well, they move. The circle moves. So the circle goes from here, like this, like straight up. If you're at the North Pole, not the magnetic north, because magnetic north would be a little bit like this. So as you move towards the equator, it moves down, right? Like the image showed, and that's what we observe. So,
yeah, but it doesn't add up.
We point
the closer to the equator you are, the less you should see circles.
Well, we're pointing the camera at the North Star. Like, we're not pointing it at the North Pole. We're identifying the North Star, and we're pointing the camera at the North Star.
Yeah, it just doesn't add up to me. Like, even when I was still a full-on helioist like yourself, and I still believe that, I still couldn't make heads or tails of how the star trails work, because why are we always looking up at the pole from either side of the Earth at night and can see a pole star in the first place. I mean, even that shouldn't happen every night of the year. It's like we're always looking up somehow. So to me, the stars doing what they're doing, and the way I can see it is, yes, the world might well be infinite, and so it makes more sense that there would be more and more solar systems, other suns, outside of Antarctica, and so why wouldn't they have their own star trails as well? Like it's definitely something that needs to be studied. I've got no definite answer on that one.
Well, I think we understand it with the understanding of reality that I have. Like that's the axes, the Earth, the globe, the way the explanation is that's where the axes of the Earth is. And it just so happens there's a star where we can look to see where north is from different parts of the Earth, right? And I'm not an expert, I'm not a cosmologist.
Exactly, but from anywhere on the surface of the Earth, you're always looking up at it. But we're also then on the other side of the Earth also looking up to see where there would be a southern polar star if there was one. I mean, it's just blank sky, but there's allegedly a constellation there, Sigma Octantis and whatnot. And, if there was a pole star there, we would be seeing it. Why are we always seeing it up both directions from a globe, a spinning ball? It doesn't really make sense. Like half the year we should at least be looking a different way, or even at night. I mean, we're not far enough south to be looking directly south to the pole star.
Let me. So I got this star trail thing. So, like, if we're at the North Pole, yes. So the North Pole, it looks like that, right? So it's not looking straight up from the North Pole.
Yeah. So look at all those
South
straight
Pole,
lines.
You're going to see different.
See how
it's
much
just
of the
a
world
graphical
is seeing straight lines? Yeah, but that's my point. Most of the world is seeing straight lines. It's only when you're really, really close to the poles that you're going to start to see them as going around a polar star.
Yeah. So, but people do see this, like on these different points of the Earth. Do you agree with that?
Yeah, but we're not far enough south, is what I'm saying. Like, it doesn't make sense.
You aren't. You
we
aren't.
agree that the reason we see a sunrise and a moonrise is because of the Earth's spin, then the stars should be more or less behaving the same until you're very, very close to the poles to start seeing the circular star trails around the poles. It just doesn't add up.
So I'm looking at images from South Africa, and it looks pretty good to me. Like it looks like a circle like this from South Africa.
Yeah, exactly.
Looking
but why
like
do we see that
south.
also from Australia? And also from
isn't
South
Australia
America?
further north?
Yeah.
So South America, you see that, and from South Africa, you see that.
But
So it depends on where you're at, your latitude is,
south.
or your longitude, right?
Yeah, most of the star trails from Australia, I think, were done from a place called Coonabarabran, which isn't actually that much further south from where I live. A few hundred k's or something. It's not a huge amount. And the fact that we can see perfect star trails from here and there, it doesn't make sense.
What do you mean perfect star trails?
Perfectly circular star trails around the center point. We'd all have to be virtually wrapped down
Yeah, they
the
look
bottom
like
of
that.
the Earth, pointing outwards at the pole.
Well, they're not perfectly. They're still up, right? So it's something like this, you think? Like if you were to draw a line from you to the center?
I can't understand how a pole star could even be fixed. Surely it should rise and set as well.
So
how can it be
I could probably do that. Like if I spent the time and we did the trigonometry, I could probably figure out what it should look like from where you are at, just with basic trigonometry.
Okay, I've thought of a model that anybody should be able to do, and I did propose it again the other day, and just said if we have a globe, a normal classroom globe, and we sit it on its tilt, and we use the laser to point out from either pole exactly. So you've got two pole stars, and we affix two little cameras onto this globe. And technically, we should be able to put it in a big warehouse room and put a heap of Christmas fairy lights or something around just to imitate the stars. And we should be able to align each camera from either side, let's say 45 degrees, towards the pole stars. And then by spinning that ball, I don't think we'd get perfectly circular star trails around the pole star. I think we'd struggle to even stay aligned to the pole star. I just don't think it could work. And that's my logical deduction after years and years of thinking about this. So if anybody can do this, make this model, I would love to see it because I don't think it can be done.
Well, it's just engineering, right? If we can keep it that stable enough and to make sure the errors aren't that great. So, I mean, we're talking about celestial bodies, right? The Earth is huge. Stars are very, very distant.
That's what you need.
It is a different scale. So
about them being billions of light years away.
No. I'm saying you could do it. You could simulate it in a warehouse. You just would have to have precise enough equipment to remove as much air from the measurements as possible. You could do that. It should work just fine.
You don't have to worry about the air. It's got nothing to do with that. It's just a matter of having the time-lapse cameras pointing out at the fixed pole stars and showing how, as the Earth spins,
I'm just saying
that all the other stars around it are making perfectly circular star trails until you get close to the equator. So it shouldn't be that difficult. It should be reasonably.
Are you saying look at the actual stars with the camera? The actual stars in the sky?
Camera on either hemisphere at about 45 degrees pointed towards a pole star at each side. So one up, one down at the pole stars, which are created by lasers coming out from the Earth. So there can be no denying they're polar aligned. You know, they're definitely true. And then all the other stars surrounding it that are just light sitting there, they should also appear then to make perfect circles around it.
I mean, we have star trail pictures. I don't understand the difference. I think you need to draw a picture to see what you're trying to explain, because I think we have pictures and people that have done it since we've had cameras to show the star trails in the sky.
Exactly. But so it doesn't make sense on the model according to the belief of the model. So what we're saying,
I think it only makes sense on the model.
No, it's the same idea as, you know, looking at basketballs and saying, well, basketballs are round, therefore the basketball court is flat, is round as well. But, you know, that's the same sense of saying that the star trails doing what they do defines what the Earth is. And
so
if
don't
we
you
tried
have to
to
have
make the model, if we tried to make that model of the Earth, it just isn't going to work. I'm telling you.
And if we made a model of the Earth with models of stars like that CGI, I did.
No CGI,
right?
Just do it like in reality with actual
like
light
that
in a warehouse room.
Like that. Oh, okay. Yeah, we should be able to do it. And there will be error because you have to be able to spin the thing. So it's going to have a little. I'm not going to say it has any measurable wobble. I'm just thinking as an engineer that you'd have to make it where it doesn't move.
That's just assuming though too, that the Earth is staying perfectly still and not orbiting the sun. Because, I mean, as soon as we bring in the orbit of the sun, this is the equivalent I've often used as an example, just online chatting to people and stuff, is saying, like, if we had a camera and we looked at a Ferris wheel in the distance, and the Ferris wheel's at night, so it's covered in lights, and if we took a time-lapse camera picture of that, you know, over a period of a few minutes, it'll make perfectly circular star trails of the lights on the thing. But what we have to try and understand in the heliocentric model is that we should be doing that from the back of a car or back of a truck. So we've got our camera mounted on it, moving 65 times faster than what the Ferris wheel itself is rotating. And you know for a fact that those star trails are going to be long, glaring streaks. And this is what the heliocentric model is. We're rotating around the sun.
Why would the car have to be moving?
Because we're orbiting the sun, are we not? Isn't that what heliocentrism is all about? We're orbiting the sun.
Yeah, very slowly. Very slowly.
1.6 million miles a day. 66,600 miles an hour. We're only rotating
1 degree a day.
1,040 miles an hour. You know,
come on, Iron Horse.
It's faster sideways. Yeah,
but
that's what
we
I mean.
are seeing the stars are very, very far away, right? We're seeing the sun is very far away. So you can't just hold one thing static and ignore the rest of the explanations in the model. I mean, that's sort of unfair, right?
Well, I'm
when we see
the benefit of the doubt when I say we don't assume the 65 times faster rate of motion just to have star trails. We should be moving linearly 65 times faster than we're rotating. So a star trail, you know, just gently going around the middle star, we're actually going 65 times faster to orbit the sun all the time.
So we're not moving hardly at all in reference to the stars. I think there's parallax or something you can measure that, but we're not moving that far in reference to the stars.
the parallax of the stars should actually change far greater if they are as far apart from one another as we're told. If we're told, like if we look at a constellation and this star is, say, 55 light years away and that star is 155 light years away, then as we're moving, they should move in relation to each other, even more so. But they don't. It's almost as though every single star moves exactly the same right amount of speed at the right time all the time, just for insignificant little blue dot Earth. And that just makes no sense. In the heliocentric model, again, everything works to exist to look the same for us here on Earth. It's another thing that just destroys heliocentrism.
Yeah. I mean, but that is because we see they're very, very, very far away and they move very, very slow in relationship to each other. Right? That's what we say. So we explain all that in the explanation.
Yeah, but it's we're the ones that are doing all the motions too, independently of what they're doing. So even if they're moving slowly in relation to one another, you know, we're told the sun is moving 500,000 miles an hour, and that adds up over time. You know, if we're going around the sun as the sun is moving through the galaxy, that's obviously all the stars are moving in motion with the sun. So you're saying the whole entire universe is heliocentric, not just, you know, 8 or 9 planets going around the sun. You think the whole galaxy does?
No, I don't believe the sun is the center of anything. Actually, it's the center of its own gravity well. Let's say that, right? So
that's what heliocentrism is all about. The solar system, sol, yes, the sun. The
I agree.
Earth goes around the sun.
But that's how we use to understand the rest of the cosmology is by that model, looking at celestial mechanics with our solar system to try to understand how the galaxy works, to try to understand how the galaxy works in relationships to others. The heliocentric model is not the center. The sun's not the center of reality. That's not what we believe, right?
No, but it's what you believe, though, as far as the solar system is concerned.
Solar system
is that the Earth, for us to measure 1 year, is for us to go around the sun once, and a day,
and we do move
rotating on our axis once every 24 hours. So all these motions should be showing completely different motions of the stars. They should be completely different every night. The whole model falls apart the minute you invoke heliocentrism to it. If we put the Earth flat and stationary at the bottom of it all, and what we see above us is the things doing as they do, as we observe it, that works. It works perfectly fine. It repeats year after year after year. Constellations remain exactly the same. The sun takes exactly 24 hours to go around above us. The moon does its own little thing, 50 minutes slower per day. It works. So your model is
in the time scales. In the time scales we measure, in the time scales we experience, it works, right? But the eventually it takes 230 million years, according to the knowledge of physics we have, to rotate around the center of the Milky Way. So we will change positions in relationship to the center of our Milky Way, to other galaxies and stuff like that.
But don't you think it's rather
over time? It's just so slow.
Over such a long period of time that none of us are going to be around to see it or witness it. It's rather
convenient,
isn't it? I mean, back when the Georgia Guidestones, before they got demolished, every night of the year, you could look through a hole drilled through it and see Polaris fixed exactly. You know, that thing stood for over 40 years. That Polaris never changed. There are other things like one of these, it's a war memorial thing, and it lines up on the 11th, 11 o'clock every year, whatever. And the lights coming through 5 different pillars line up perfectly every year. None of those things would work. We'd have to wait 200 and however many million years you said before that would line up again exactly. But they work all the time, consistently. And it's just convenient to be able to say, well, in another 30,000 years, we'll have a different pole star or something when no one's going to be around to see it. It's just an argument from convenience, not based on facts, not based on observations. So I don't know why you would even try and argue them as a point that you can defend in a public debate.
Well, it's based on observations. It's based on our understanding of reality. It's based on physics, right? Based on the laws of planetary motion. Based on,
absolute fantasy. There's been no detection of planetary motion. Like, what's your best proof that the Earth itself is moving? Give me one example that proves the Earth is moving.
I do a test all the time to measure between two locations that require that gravity exists.
That doesn't prove the Earth is moving. Sorry, like I want some
It has
actual
to move
evidence that the
to
Earth
exist.
is moving.
Actually, see the sun, when the moon, we see the sun.
Yeah.
We send ships up to. We send a ship to Mars. We send ships all over the place.
You don't really believe we've been to Mars, do you?
The Webb's telescope. We're taking beautiful images of like distant celestial bodies.
But we know for a fact that nothing's ever left low Earth orbit.
You say
nothing ever.
You say it's fantasy. Come on. Okay, let's pull that back a little bit. You say it's fantasy, but you're saying your own subjective truth is real.
Yeah, but I base it on reality, and I base it on the deduction of things that can be actually measured. Like, I mean,
do you think people can have delusions? And I want to be clear, I'm not saying you have delusions. Do you believe people can have actual delusions and that are not real?
Oh, absolutely. I mean, obviously, I'm talking to somebody who thinks we've sent rovers to Mars. A ball of gas or a light in the sky.
Now, my knowledge is subject to the information, right? So it's subject to the knowledge I have, right? It's not based on me experiencing it personally being on Mars, right? But I don't think my experience is necessarily accurately portrays reality, right? I can be wrong. Like I know people that suffer from delusions.
I mean, a lot of people think that
family members.
There is a part of our brain, they call it the reptilian mind, that cannot discern between what we see and what is real. So when we watch a movie, there is a part of our brain that is fully deceived and thinks that's real. And some people take that to the next level and think that they do live on some sort of world like, what's that movie that just came out again? Avatar? Yeah. So people actually take this stuff quite seriously. A lot of people take Star Trek seriously. They take all sorts of things seriously, Star Wars. It becomes a part of their reality to the point they can't discern between actual reality and the fantasy anymore. And we do spend a lot of our time in our imaginations. I mean, we dream every night. I know I do. I have some far-out vivid dreams. Even last night I had some wicked ones. But, I know the difference between when I wake up, what was fantasy and what's reality. And I think that's the difference between being delusional and being grounded in reality. And basically being grounded means earthed. So if you're not earthed, if you think the Earth is a spinning space ball hurtling through space, you're not grounded. Your mind is out there somewhere. So you are lost in space, literally.
My knowledge and that I exist. And I think we use to try to determine what is objectively true, to remove things like my own personal subjective experience about reality. And really that's it, but I don't know. I don't have much else to say on the topic.
This might be an opportunity to jump into the Q&A. Want to say a couple of things housekeeping-wise, folks. In particular, our guests are linked in the description box below. If you haven't checked out their links, what are you waiting for? You can even open up a separate tab in case you want to keep watching this debate live. In addition, we also link our guests in the description box for each podcast episode, as this debate will end up on the Modern Day Debate podcast, which you can find at Spotify, Apple Podcasts, every single podcast out there, you name it, we are on there. We're going to jump into the Q&A, so if you happen to have a question, you can still submit. We're probably getting to that point of where it might get read, so we're going to try to move fast. So, want to say, in addition, if you haven't yet, consider sharing this video, as that really does help Modern Day Debate grow. We do appreciate when you guys do that, and we see the stats show that a lot of you guys really do, so we want to say thanks. Seriously, we do appreciate you sharing. So this first question coming in I'm assuming that Iron Horse is using the restroom, so we'll give him just a moment. But want to say, Ozien, thanks for being with us. It's been a juicy debate tonight. I hope you've enjoyed it.
Yep.
Amazing. All right, we're going to jump right into these. Let me at least start with one for Ozien, and that way, even though Iron Horse is in the hot tub or wherever you might be, we can nonetheless jump into these.
I had to get the air conditioner.
Did you like my video? I'll send you that video, Iron Horse, so you can have it with your NASA tattoo. So,
which one?
The one with the lasers coming out of your eyes. Anyways.
You have a NASA tattoo? Do either of you?
I've got a horse.
This one from, thanks so much, Thunderstorm says, couldn't the Earth be considered irregularly shaped with a spherical atmosphere as a more accurate depiction?
No. I mean, the nature of water itself determines the shape of the Earth. We can't go beyond that. That is the discerning point of what we know the shape of the Earth to be. Now, the atmosphere could be slightly rounded. I don't deny that. I think maybe we have a dome, and that's the way that the sun, when it projects through it, creates the amount of sunlight that we see over the seasons. But to think that we could be a spinning space ball going through space with an atmosphere, if the universe is a vacuum, just doesn't work. The atmosphere will just dissipate instantly to the vacuum of space.
You got it. Thoughts on that, Ozien?
I just want to say if the atmosphere is curved, there's no reason the water can't be curved either. But it doesn't escape to space because of gravity.
You got it. This one coming in from Dario DeJuric. Let me know if I'm pronouncing it right. It says, amazing intro, Iron Horse. You already won this debate. These globies have no chance of going up against you in a debate.
Thank you, brother. I appreciate that. I finished writing it again this morning. I thought I'd be able to have this done days ago, and I was going to have a video presentation or picture presentation, everything. And I realised just how much information I have in my hands. It's just unbelievable the amount of evidence to prove that heliocentrism is wrong. So it's a pretty easy debate, really.
Juicy. Well, this one coming in from, do appreciate your question. DJ Moss says, question for Iron Horse. Calculate steel beam strength, which is supported ends, and there is 100,000 kilograms at the center point. Let me just double check. It's a lot of zeros. I want to be sure I got that right.
A lot of zeros.
10,000 kilograms at the center point. You can use only math without gravity. I haven't found a formula for that. Can you?
I'm not an engineer, so I'll give you that, but I can work out that 10,000 kilograms is 10 tons. So that's pretty simple. I don't know the tensile strength of steel off the top of my head, but I do know that everything has density, and then the volume of the so-called density is what gives it its weight. And so depending on the density of the steel and the density of the what sort of weight was it that I guess it doesn't really matter. It's just 10,000 or 10 tons on a steel beam. How long was the steel beam exactly?
They did not mention. They just said, question for Iron Horse. Calculate steel beam strength, which is supported ends. I don't understand English, like the English of that. I don't get it. They say, which is supported ends. And there is 10,000 kilograms at the center point. You can use only math without gravity. I haven't found a formula for that yet. Can you?
No, because he doesn't describe how thick the steel beam is, how long it is, how far the ends are away. So it's not something that can be easily calculated. But yeah, we can basically say it's all boils down to density. And yeah, go ahead. You seem to have an idea.
I think he's like, if you get a really long plank, say take a long plank of wood, right? And you put it put them on two fulcrums. The longer the plank, you get some sag in the middle, right? And the longer the plank of wood is, the more sag you get in the middle. And the reason we say there's sag in the middle is because of gravity, the weight of the plank pulling it down. And he's saying with these steel pieces, these steel beams, whatever they are, as I think he said 10,000 kilograms of force or something like that.
Yep.
Yeah. So that basically just boils down to the density, the resistance factor of the steel beam itself. I know you like to invoke gravity, but gravity basically just means weight. It doesn't mean anything more than that. And weight in its own right is technically a force. And the two opposing forces is the weight versus the resistance factor. So it's the resistance factor of the steel beam And generally speaking, when they talk about gravity in a formula mathematically, they're talking 9.8 meters per second squared. That's the rate of any sort of mass falling in the medium of air, which has virtually no resistance. So that's all that the G is in that formula. It's just distance over time. It's got nothing to do with an actual force whatsoever.
You got it.
The G and the G formula is for gravitational constant when the mass times mass divided by the radius squared between the center of the two objects. But yeah, 9.8 meters per second, that's all.
How do you calculate the radius? You know, like, where do you get R value?
From the center of the mass.
Yeah, and that
the center of each
goes all
mass.
the way back to Eratosthenes talking about, measuring shadows of sticks, and that's how you get R value. That's still the same way we do it today. Like, I've tried very hard to find out how we measure the circumference of the Earth today. We still do it the same way Eratosthenes did, as measuring shadows of sticks, and that works just as well for putting a couple of, say, bottles or something standing on the table, shining a torch down on, and you can work out exactly how spherical the table is with that same method. Good luck with that.
Yeah, we have satellites in orbit that we can measure the size of the Earth.
Satellites in orbit. Forgot about it.
Yeah.
You got it. This one coming in from, do appreciate your question. Dr. Mantis Toboggan says, Iron, you said you had 10,000 debunks of the Helio model. Why didn't you show any?
Well, because I'm not that technologically advanced in my ways, and I'm doing this through a phone. Once I learn how to use my laptop and make a presentation, I might present some of those 10,000. But I think when it comes to a debate, if you can't argue something logically, if you're relying upon visuals, I think, it works both ways. I prefer to do it as logically as possible. And I think I presented a case that proved my side of the story.
You got it. Thank you very much for this one. Coming in from Nick says, would the physics work equally well if the sun revolved around the Earth? If so, why must we discount our everyday experience and observation?
Who's that for?
Probably for me. So all the math is much more parsimonious if we do all the calculations based upon theory of relativity and use the sun as the center of the solar system. But the sun is only the center, the gravitational center of itself, right? And then it affects everything else in the solar system. Just calling it the center is sort of convention, I would say. But
how does that make sense if it's the gravitational pull of the sun, which allegedly holds all the planets, including the Earth, going around it as it's hurtling through space? So you can't just say the sun's only gravity to itself. It's obviously gravity to all the planets, the wandering stars, against the background of the fixed stars in the heliocentric concept. So what you're saying doesn't really make much sense.
This one coming in from Nominal says, quote, the invisible matter that we can't detect is called, quote unquote, dark matter. And then they say that that's what NASA says.
Yeah.
So theory.
Oh, you go ahead, Ozien. Yep.
Yeah. So I'm not a cosmologist. Just grant that, please. So when we look far distance out, we see some lensing effect, I believe, with our observations that isn't explained by the matter we see. So right now we have this placeholder for dark energy and dark matter to explain our observations for really distant objects. And there are some other hypotheses they're speculating on, like MONS, which is modified Newtonian dynamics, and try to harmonize dark matter without including dark matter. But it just might be the case that dark matter exists. What we do know is all of our testing that we do for theory of relativity works.
So basically what you're saying is that gravity is the attraction of mass. But in order to stop everything colliding into a singularity, the universe must be teeming with dark matter. But then to stop everything from expanding perpetually outwards, it's also for the dark energy. So everything based on your gravity disproves gravity. It works out to be a nonsense theory. Gravity sort of works when we're talking about things here on Earth, but as soon as we start going cosmological scale, that's why you have to invoke dark matter and dark energy, because obviously it has to be there. It can't work any other way, but it's not because you've seen it. It's just dark, it's invisible, and we have to have it because otherwise everything falls apart. It's the way science works. Is you make up one nonsense thing, you have to believe in another nonsense thing, and another nonsense, another, and another. Whereas if you just observe reality as it is, you don't have to make up anything.
You got it. This one coming in from, do appreciate your question. Beamsy says, question for Iron Horse. With the way radar is cross-conformed by sonar and LiDAR, why can we not use the readings we get from radars to get exact distance and movements of planets?
Well, I don't believe that planets are physical. That's probably why. We're just looking at lights. And I believe I brought it up in my opening when I said that they're sonoluminescent, or they're electrical in nature, and sonoluminescent is basically the vibration of sound creating light, and that is how we see the light from stars. It doesn't mean that they're actually a physical thing at all, the way we think of it as a physical thing. So, I believe that radio and radar is basically next to useless when it comes to measuring non-physical things.
You got it. This one from, let me see if the name was attached to this one. I think I might have missed it. But whoever it was said, why? Go ahead.
Sonar doesn't travel through a vacuum. It has to travel through materials, so that you can't use sonar to measure distances, cosmic distances, because sound does not travel through a vacuum of space. But light does, and radio waves do, radar does. So if you could focus a beam, I think they do that for the moon. They can measure the distance to the moon with radar.
Yeah, well, that's why I say that sonar only works in our atmosphere. Like if we send a camera up on a weather balloon up above a certain height, generally this 12 to 14 mile range, above the atmosphere itself, where we have atmospheric gases, you don't see any stars whatsoever. So I believe that the stars that we see, we're only seeing as a result of looking up at them through the atmosphere, and it is their frequency and vibration through sonar luminescence that creates the image of a sparkling star, which is basically the prediction many years ago that the stars will fall to Earth. It's not as though they're actually falling physically to Earth. It's just that by understanding the nature of light and how it works, we bring the stars much closer to Earth, because that is where they exist, in our atmosphere, very, very close. And they're not thousands of light years away.
Starlight doesn't vibrate our atmosphere.
I believe
it's not sound.
I believe that we should see stars more clearly in high altitude balloon footage, if stars are what your theory of them says they are. I believe it's all related to our atmosphere, that the atmosphere is the most important fundamental aspect of existence, including light, including our ability to breathe, pressure, and all the rest of it. All physical existence exists as a result of our atmosphere and atmospheric pressure and the visible lights we see as well.
This one coming in from,
I think we need heat. Go ahead.
This one from Nick says, is it a problem for the globe model if those who argue for it can't get their point across in a simple and logical way?
Physics isn't simple. Cosmology is not simple. People spend their whole lives studying different specific branches of physics, so it'd be unreasonable to expect any single person to understand everything.
But it should be able to be described in a pretty simple way. Once you understand something, the whole concept of being able to understand something is being able to break it down and explain it in a way that even a 5-year-old can understand, even at its most simplest form. So if you can't even explain it to, say, a 50-year-old, then you're probably lacking something in your knowledge.
You got it. This one coming in from.
I think I did that, but
do appreciate it. Let me just go over the standard list. What says, why would the whole astronomer community from the whole world conspire to lie to us? Iron Horse.
I don't believe they're conspiring to lie to us at all. I just believe that they've been taught on the foundation of a lie in the first place, and it seems logical to them. They'll struggle to break free from it, because the minute you try and break free from it within the community, you're going to be ostracized and you're going to be treated as an outsider, treated as ignorant. I know all about that. I've been treated like this for years and years by people, but I stand by my guns and know what I know. And anybody that's trying to be somebody in the big wide world of stuff, they have to follow the dominant party line. It's simply how it works. If you don't, you get ostracized, you're treated as an outsider, and you haven't got a hope in hell. So if you want to be making a living out of doing that sort of stuff, like people like Neil deGrasse Tyson do, you just keep telling the same lies that you have to tell, or you get exposed.
This one coming in from, do appreciate it. This one didn't have a name attached, but they said, why don't bacteria not fall off our bodies when we spin? Answer, gravity, they say.
Gravity. I would think that centripetal force should do the opposite, and if we're spinning, it should send them flying off. It's obviously they just don't have enough mass, and there's that thing called, for want of a better term, stickiness of moist things, living things, that they'll just stick to us. But yeah, technically, the faster we spin, the more things should fly off of us.
You got it.
I can describe very disgusting things we do to discharge bacteria, right? Sneezing, flicking a booger, I don't know, all that stuff. But yeah.
Yeah, we feel it like spinning.
Very interesting. That is it for our questions. We do want to say, folks, want to encourage you. One, if you haven't yet, you can always check out our guest links in the description box. We really do appreciate our guests. They're the lifeblood of the channel, folks. And in addition, you can also find their links at the podcast description box as well. I want to say a huge thank you, Ozien and Iron Horse. It's been a true pleasure to have you guys here tonight.
Much appreciated, James. Thanks for having us.
My pleasure.
Thank you, James. Thank you, Iron Horse.
Cheers, Ozien.
I will be back in just a moment, folks, with a quick update on upcoming debates. So stick around for that post-credit scene. It's going to be a short and sweet one. We'll want to say thanks again, everybody, for watching. And most of all, thanks so much, Ozien and Iron Horse. My dear friends, I want to say thanks so much for being with us. I'm loading up the Zoom as I want to get a quick note in and just saying upcoming debates that you want to hear about and that you don't want to miss out on. Hey, I do encourage you, if you haven't yet, hit that sweet subscribe button if you haven't, as we have many more juicy debates coming up that you don't want to miss. We're excited about that as Modern Day Debate continues to grow. And my dear friends, we're excited about that. We believe that Modern Day Debate has a very important place in the YouTube and podcast world. In particular, we want to provide a level playing field so that everybody can make their case on a neutral platform. That's important to us, and we believe YouTube deserves a better class of debate channel, and we're going to give it to them with that. So I want to say thanks for your support. Seriously, it means more than you know. I want to say, if you haven't yet, hey, yeah, consider sharing this debate. Maybe you have a Discord group or a Facebook page, or maybe just a friend. You send a text message. You can hit that share button right below the play screen, you could say, in terms of where you're watching me, and you can share the link with all sorts of people. We really do appreciate that. Is that, you could say, third-party testimony in terms of us being a neutral and fun channel where we host interesting debates that you don't see on the mainstream news. We do appreciate all your shares. So seriously, thanks for doing that. And I want to say, in terms of our upcoming debates, thanks Sideshow Nav. I see you there in the old live chat. Thanks Winston's mom. Good to see you there in the live chat. I see you. Hacking the Headlines. Good to have you with us. I see you there in the old live chat. Joe the Toe, thanks for dropping in, as well as Joseph Lepolito. Let me know if I'm pronouncing it right. We're glad you're here, Joseph. As well as Dylan Motes, thanks for dropping in. And Jupiter Darman, glad to have you here. And Rachel Ann Hicks, happy to have you with us, as well as Adam the Inquirer. Thanks for dropping in. I see you there in the old live chat. Sam Pedro, glad to have you here, as well as One Nation Underground. Thanks for dropping in. Thanks for all of your support, folks. Seriously, in terms of those upcoming debates that I mentioned that I would share in this post-credit scene, let me just pull this up right now at the bottom right of your screen. Got the TikTok one. There we go. Okay, as I mentioned earlier at the very start of the debate, if you missed it, is Christianity rational? That's going to be the topic as we host Stuart Nettle and Matt Dillahunty. They've debated before, and it was a hugely popular debate. That was on whether or not God exists. This one's going to be on, in particular, whether or not Christianity is rational. You don't want to miss that. It's going to be a fun one, folks. Do hit that subscribe button if you haven't already. In addition, some of the ones that I don't have on the overlay here, but you can see at our homepage on YouTube, you could say, in terms of Modern Day Debate, we have our upcoming debates shown there in the very top playlist. And you can see we have Socialism versus Capitalism this Monday. We'll also have Theism versus Atheism on Tuesday. That's actually going to have Ozien again. And then we're also going to have, likely this Thursday, is going to be that debate that I mentioned at the bottom right of the screen. That's still being sorted out, so that's not confirmed. I've got to still figure that out for sure, what day that's going to be, but within the next week is our goal. And we have a lot of debates still coming up that right now I'm like, I can't even take all of the requests. So want to say thanks for your support, you guys. Seriously, it means more than you know. And want to say hello to more of you in the old live chat. I Killed Earl, good to see you. Roshi Strider, glad to have you with us. Thomas Morgan, happy to have you here. Jacques Polymer, thanks for dropping in, as well as Thomas Morgan and Aussie Gold, good to have you there. Ms. Sweet, thanks for dropping in. Says, much love to everyone. Thanks for your positivity. That means a lot. As well as Rachel Ann Hicks, thanks for dropping in. And Richard Amorike, thanks for being with us. We're glad you're with us. KK Westbury, glad to have you here. What? I see you there in the old live chat. I think I saw 2 people with the account name What? ? So I want to say glad to have you both here. What's? As well as Thomas Morgan, good to have you here. And Richard, yes, thanks for being with us, Richard, and Thomas Morgan, thanks for being here. Want to say, my dear friends, I love you guys. You guys make this fun. Thanks for making this a blast. Thanks for all of your support of Modern Day Debate. If you haven't yet, another thing to consider, hit that like button if you feel compelled to, as that really does help. That helps boost our video in terms of when it shows up in the rankings, when people search for debates like this. So we do appreciate that. That's another way we appreciate your support. And thanks for doing that, as the amount of likes I've seen in the statistics for the channel are also huge. So we really do appreciate you guys supporting our neutral channel. And I see there in the old live chat, Hacking the Headlines and Red Pill Matrix, glad to have you here. Projects, thanks for dropping in. I see you there in the live chat. Perfect One, good to see you back. And want to say, though, thanks everybody for your support. Seriously, I'm excited. I'm pumped about the future. We're going to keep on learning, keep on getting better, and we're going to keep on putting out better and better debates. So thanks for all of your support. We love you guys. Keep sifting out the reasonable from the unreasonable, and we'll see you next time.